from University of Waterloo. This is an old paper, but I think like what the person presents, our teacher presents about how to find papers is probably slightly older, but I think the how to read is still relevant. Anyways, why or when do we read papers? So first, class assignment. I'm probably going to be reading papers in college. I know in AP Bio, we had to read a summary of a paper, and then also read some papers for a final project we have to do. Literature review for your own research, should you want to do some in either high school or college. This is both because research kind of builds off of each other, so you have to read what's already existing to do more. And then presenting to the Radical Researchers Society. So this is the first step in presenting. For a club at Fremont, but also if you want to present a paper, or even your own paper. Yeah. And then finally, to stay up to date with your field. So this is more relevant to probably me, because I'm majoring in CS, but also professors, or even my mom who's a doctor. She has to read papers constantly to stay on top of what are the latest either technology or methods to cure or help patients. And then for people in CS, I mean, the field's moving very quickly, so reading papers constantly to make sure that you know what the most cutting edge techniques are, very important. And then finally, to learn. A lot of stuff out there and a lot of facts or whatever people say is usually backed by research. And now more than ever, you can just find information anywhere. So being able to cite sources is super important. It's called, side note, there's this idea called burden of proof, where if someone creates a claim, whoever made the claim must provide the sources or evidence to back up their claim. And that gives you a way to double check if they're actually saying what's valid. Usually at this point, I'm questionable to believe stuff unless they actually have a paper or some evidence backing it. Usually papers are the gold standard of evidence to support something. And learning, because at least in CS nowadays, because everything's moving so quickly, you learn less from textbooks and classes, because those are probably summarized after very quickly, a year or two, very late, 5 or 10 years. So reading papers is published within 6 months, and you can get your hands on it. Okay, so a typical paper structure and what is in every paper, what we can expect in every section is, so first you have the title, you have the hook, because the title usually has a hook in it, so people actually read the paper, just like any other newspaper article, I guess. As the author, just notable to point out, because usually research kind of revolves around key authors, or researchers in this case. There's the abstract, which is the entire paper in 250 words. Basically, it'll usually quickly cover, kind of hooky again, so very important contributions, what this means, and also quickly about what metrics they use and what they measured. And then the introduction, again, is a little more like the abstract, so a summary of the paper, a little bit longer now, but it actually has more about the prior research. So the introduction will have all the contents of the paper, but more emphasis on what's been done before this paper came to be and what this paper builds off of. Then the prior research has a prior research. So how did other people get the numbers or answer the question that we're trying to answer, or tangential questions to the one we're trying to answer. And then methodology, how did I try to answer this question? This is usually specific to the experiment. There's many different ways to try to answer a question, usually. And methodology will present one way if someone's trying to get the answer, because usually these questions are very hard to just directly measure. So the I guess when people say rigor of research, it's mostly in methodology, how well they actually did their stuff. And then there's results. So the results are numbers, which they got from the methodology, pretty self-explanatory. The people usually don't add much else in here in the results section. And then finally, discussion, which is discuss the numbers. So this is where you finally talk about trends, any notable points about whatever numbers you've got, or any, I guess, notable features that you weren't expecting. And then finally, conclusion. Again, conclusion is again a summary of the paper, but now this time it has more of the discussion and future research. This may have like, oh, what are the implications of this research? What are for future ways to explore more or dive deeper? Some people may also have not exactly a disclaimer, but something similar where they say, oh, these are some limitations. It would be either limitations in how broadly the research can apply. For example, if they used it in a simulation or a game, they can have limitations to real world or other games, for example. Yeah, and then, actually, yeah, we'll just leave it at there. Cool. Any questions? Yes.
Like, I happen to know that math papers are nothing like that. Like, it's usually kind of quite different. So, like, how much does it differ, like, subject to subject in general? Like, are most other papers like that, or are there quite a few different styles, but this is just most common across different subjects?
I think you'll find this most common in, like, either life science or physical sciences, anywhere where you need to do experimental testing to get data and results. No math papers, I feel like there's more proofs involved. But like, for example, biology, you need to do a lot of testing in the real world. Same thing goes for any sort of like geology, physics, or physics also probably more proof-based.
Yeah, and I guess maybe like the AI paper you presented
The AI paper I presented on is also more empirical because people want numbers about how much better your model actually is. Yeah. And then also that, I guess, yes. So this would probably also apply to not just like, not just to research questions in sciences, but also if people try to, in technology or engineering, if people propose a new invention or something, or a new idea to do something better, then kind of the results, instead of like answering a question about nature, will now be results about how good your thing is compared to something else. Okay, and then 3-pass approach. I think you guys also saw this. So the first pass is a paper worth reading, basically. When you have to cover a lot of papers. This is also when you have to first get to know a subject, you read a lot of papers. You go through mostly this stuff. Title, abstract, introduction, conclusion, references. Again, just to get a summary of the paper. References, mostly because, again, research always has sequels. It's like one researcher will probably publish one paper and then publish another paper and then publish another paper on the same. No, one researcher will have a lab that's dedicated to answering questions in this space. And then they will publish paper after paper that directly builds upon previous papers usually. So by going to the references, you may be able to find whoever the lab was, or also the references will help you find other researchers in the space that are credible. You can also see like, oh, these papers reference each other or stuff like that. Category, and then this is kind of the 5 things to pay attention to. So category, like what type of paper is it? It can be answering a question, or it can be measuring a invention, or comparing their own invention to someone else's. Context, so is like what, where does the paper position themselves in what space? Sometimes they can position themselves in the real world, or in a game or simulation, stuff like that. Context, no, correctness. So how correct is this? I have an example. So the correctness is mostly how valid are the assumptions that the paper makes. I have an example here that I'll go to later. And then finally, contribution. So what does the paper actually contribute? Sometimes people do a lot of research, but it really just confirms someone else's points. You really want to try to find is what new thing does the paper contribute, and really focus on that. Otherwise, just go to the original work. And then finally, clarity, how clear it is. Because some papers are just very wordy for no reason. Okay, and then also pay attention if you're writing your own paper, because as you guys probably read, reviewers go by these papers really quickly as well. So you want to make sure your paper kind of hits all of these points. Okay, so the example is grep all you need. So I'll just talk about it a little bit. So basically, this paper, for those who do not know, grep is this very old way of searching. It's basically Control F, where it finds the exact. If you search for a keyword, it'll find the exact keyword in a file space or in text or whatever. And then we have now vector search, which kind of does similarity. So if you search for like, it's kind of like doing synonyms, for example, where grep will find you the exact word for word. Vector search, which is what modern AI uses to search through files, search through whatever, will find you synonyms. And this paper kind of was writing the question of, hey, is grep, because this vector search is very complicated, very slow, so is grep actually faster or does it do better? And the paper result comes out saying, hey, grep is actually faster and it performs better, gets you higher accuracy when you're trying to search for, like, for example, if you're trying to search for the date of your swim competition, when you're like typing about how, when you have a conversation with AI about how to register for the swim competition, you can search up like date or something and the grep will find it far faster than the vector search. Now, that's all great, but I think this is why this is an example for the correctness. Part of the assumption that they do make is that the word date is always used. If you were talking about registering for the competition, but they use a synonym for date, maybe they say, hey, the competition is going to be on whatever, but they actually do not use the word date, then grep will not be able to find it. Vector search can. And again, these are assumptions that the researchers made. They assume that date or whatever word or topic you're trying to search for is explicitly stated. That way grep and both the vector search can find it. But that assumption may not always be true. Cool. Does that make sense? Cool. And then survey papers, an honorable mention. So first pass, like survey papers give you a survey of the topic. So it's, I think, more bang for your buck to read if you're just trying to understand it very vaguely. The second pass. What claim does the paper make and what evidence does it have to support the claim? So this is where after you read it, kind of understanding exactly what the paper is trying to propose and again, what evidence does have to back it up. Very simply, it's just going to be the independent variable, dependent variable, and then also slightly more complex, like statistical significance. Did the evidence that they create, is it just, random chance that it happens to be show these differences, or is it actually due to something inherently like different or improved in the model from model A or model B? Now you actually have to talk about reading methodology, because this is basically how they derive the numbers and the evidence, kind of, and then the result is more evidence, and then the discussion is discussion about the evidence. So, okay. And then don't get bogged down in fancy terminology, because this is where there may be tests and experiments and tools specific to the field they may not get. You can search it up on Google. GPT can probably help as well. But otherwise, you could just assume that the tests that they use are probably helpful or make sense for the use case, and then move on and take it as evidence. And then usually this is where figures help, because figures will have the like the measurements that they use, or measurements that they use very explicitly stated. Yep. And then the references are background knowledge. So again, if you don't know the fancy terminology, some of the references, especially from the prior research, will probably tell you about the methods or like other types of tools that they use. And then finally, the third pass, basically recreating the word. This is if you need, again, because research builds on other research, a great starting point can be just trying to replicate work. And by replicating work, you would find some of the assumptions, or you'll find more assumptions that the author has made in their work, and you can question them if they're valid, not valid. Another thing is then you can find the gaps in their work. Maybe you find a couple of assumptions you don't think are valid, so you want to test cases where you don't assume those things. And then that can be new research, and that is technically a contribution. So in like my research I presented on about can AI actually deceive, I also outputted the reasoning from each agent to see if they're actually, what thought process they have in trying to lie to the other AI players when playing Mafia. And my assumption is that the AI models are thinking. Yeah. And that they're not just, that or even the reasoning that they output to me is truly the reasoning that they're thinking about, and they're not actually just producing something fake. So that is an assumption, and the way I did it, arguably there are better ways to try to elicit like the actual true, what the AI is thinking and how it's trying to lie. But that is something that I did, and then that is some way to build up upon my work. Another assumption is that like all humans play the same, so then when I do a human comparison to AI, there may be differences in that as well. And then again, replicating results is a good starting point. So The third pass, I think I don't think it's going to be necessary if you're trying to present the paper, because this goes far more into the methodology than you would need to explain to someone else. But if you are considering trying to either verify their work or build on top of it, this is a pretty good thing to do. And then finally, finding papers topically, as they said in the paper, keyword search on Google Scholar. This helps a lot because Google Scholar also just finds you the free versions of everything if it is available. You can also follow the labs and authors. Again, going through the authors. Usually authors, if it's in a good paper, it's a good lab, and they'll keep publishing papers on the same topic. Nowadays, at least I can speak for the AI field. A lot of it is private companies doing research. So the labs that you'll go to may actually just be companies, and then the company website will have a list of the publications that it has. I know I was looking into a bio company called Boundless Bio. They're a startup, biotech startup, but then they also have their list of publications about their work. So that's a great way to learn about it. And then, let's see, survey papers. Again, that's just to get a survey of the topic, references. If you're trying to find papers on randomly, I don't for fun. I found stuff on Instagram when I'm scrolling. I find a lot of when people show cool experiments on Instagram, it'll be cool news, science news or facts across most science disciplines, physics, biochemistry, whatever. Sometimes even sociology and psychology, and they will have papers to back it up. And then that is for me a way I can find papers that are fun to read. Here are some names. I think if you're on Instagram, you've probably heard of Etymology Nerd. He started in just talking about how language differs and the interesting niches of language across all language. But then he also extends that to how us Gen Z people talk, and how Gen Alpha talks as well, and how the trends in all the memes that we have today actually still backs up some of the trends that people seen in language in the 1800s, and he cited papers about those, and those are fun to read as well. And then Hard No AI idea suit. Yeah. Cool. Okay, I think that's the end. Any questions? Yes, Recon.
So as you said at the start in the first phase, where if an author replicates another author's idea, it's better to go to the first author's idea, right?
Yeah, usually.
Now in the third phase, if you as you said, replicate their idea and do new research, isn't that basically the same thing? And shouldn't the reader go back to the first article?
So usually when you replicate it, you wouldn't publish it again. After a publication, you assume. So if you see a paper, and they reference someone else's work and say, this is how I built off of it, you can assume that that researcher has replicated the work, found points that they think are not correct assumptions to have, or gaps in the research, and then they write the paper solely on how I filled those gaps.
Okay, so
the original work,
So it's basically a new idea.
It is a new idea, yeah.
Okay.
They will probably still reference the original work briefly, but usually the paper should be new.
Okay.
Any other questions? Okay, cool. Didi, back to you.
Okay.